This is a review of our topics from week 11. We have arc lengths, sector areas, and then vectors, column vectors, and vectors in shapes. Finding the length of an arc. An arc is part of a circumference of a circle. So here we've got part of a circle. We've got 130 degrees of a circle. So a whole circle is 360 degrees. We've got 130 degrees of it. And we need to find the arc length of this sector. So that means finding the part of the circumference that we've got. So the length of the part of the circumference that we have here. So to find the circumference of a whole circle, so the circumference of a whole circle is either 2 times pi times r or pi times the diameter. Either one of those will find the circumference of the whole circle, and then we need to look at what fraction of the circle we've got. So the whole circle's 360 degrees. We've got 130 360ths of the whole circle. So this is our fraction of our circle. So we want this fraction of the circumference. And when we say of, we can change it to a times sign. So this fraction of the whole circumference, which is 2 times pi times the radius, which is 12 centimeters. If you use pi times diameter, you get the same answer. So we just need to, well, you can type this in the calculator, or if we didn't have a calculator, we could simplify this. So if we divide top and bottom by 10 on our fraction, that's 13/36. 2 12s are 24. So we've got 13/36 times 24 pi. And then we can simplify again. So we can think of 24 pi as 24 pi over 1. So it's 13 times 24 pi over 36. Now we could do 13 times 24, or we could simplify it first. So 24 and 36 are both in the 12 times table. So we could change it to 2 and 3. Divide top and bottom by 12. So what's left? We've got 26 pi on top over 3. And that's as simple as it gets. 26 isn't in the 3 times table. And it's a length. We measure it in centimeters. So that's our answer. If we type this straight in the calculator, we would have got 26 over 3 pi. We would have got the same thing. Okay, one for you to try. So give this one a go. So what fraction of the circle do we have? We've got 82 360ths. And we've got that fraction of the circumference of a circle, which is 2 times pi times the radius, or pi times d. So 82 over 360. I'm going to leave that as it is for now. And 2 15s make 30. So 82 over 360 times 30 pi. I can simplify this. So 12 30s make 360. So if I divide by 30, divide both sides by 30, divide top and bottom by 30, I've got 82 over 12 times pi. And then I can half top and bottom, which gives me 41 over 6 pi. And that is as simple as it gets. So 41 over 6 pi is my answer. Again, if you typed it straight in the calculator, you should get the same answer. Now we've got the area of a sector. So this shape is called a sector, and it's part of a circle. So the area of it is a fraction of the area of the circle. So again, we've got 130 degrees out of 360 degrees, and we've got that fraction of the area of a circle, which is pi times the radius squared. So pi times 12 squared in this case. So 12 squared is 144. And then, so if we typed it in the calculator, we go straight to the answer. I'm going to simplify it. So divide top and bottom by 10. And then I can, so 36 is into 144. That will go, but let's do it step by step. So half, top and bottom, half them again. So I've got, how many 9s go into 36? That's 4. So I've got 13 times 4 pi. 13 times 4 is 52. So I've got 52 pi centimeters squared. We measure area in squares. And the second question. So again, we've got a fraction of a whole circle of a fraction of pi times the radius squared. The area of the whole circle is pi r squared, and we've got 82 360ths of the whole circle. So let's simplify this as much as we can. So 82 over 360, I can change to 41 over 180. 15 squared is 225. So I can, well, 180 and 225 are both in the 5 times table. So I will divide top and bottom by 5. So that'll be 36 and 45. And now 36 and 45 are both in the 9 times table. So I've got 41 over 4 times 5 pi. So I can't simplify this anymore, I don't think. So 41 times 5. 40 times 5 is 200, plus 5 is 205. It's got 205 over 4 pi. And it's in centimeters squared. So let's check these on a calculator. So we had 82 over 360 times pi times the radius squared. So 205 over 4 pi. And we had 130 over 360 times pi times 12 squared, which is 52 pi. Column vectors. So we've got a vector A drawn on the grid. Write A as a column vector. So with a column vector, we write the change in X on the top and the change in the Y on the bottom. So it's gone 3 in the positive X direction. So 3 on top, and then up 1, so 1 in the positive Y direction, 1 on the bottom. So A can be written as 3, 1. 3 to the right, 1 up. Draw the vector minus 2A on the grid. So minus 2A is this times negative 2, or 2 of these in the backwards direction. So minus 2A, negative 2 times 3 is negative 6. Negative 2 times 1 is negative 2. So minus 2a is going to go 6 left, 2 down. So let's draw that on. So 1, 2, 3, 4, 5, 6. 1, 2. So negative 2a goes 6 to the left and 2 down. It's going backwards along 2a's. Question 2. We've got 2 column vectors. So A is 5 to the right and 2 down, and B is 4 to the left and 3 up. Write as a column vector A plus 2B. So 1A and then 2 B's. So A is 5 minus 2. 2 B's is double B. So negative 8, 6. And we just add them up. So 5 minus 8 is negative 3. Negative 2 plus 6 is 4. So if we went along A and then along 2 B's, we'd go 3 to the left and up 4. How about 3A minus B? So 3A's will be 15 minus 6. So 15 right, 6 down. We're taking away a B, so going backwards along a B. So let's do the x's. 15 minus negative 4. When we take away a negative, we go up. So 15 plus 4 is 19. And negative 6 take away 3 is negative 9. And vectors in shapes. Here we're told we've got a triangle, and we're told M is the midpoint of AB. We can see that on the diagram. O to A is called 4A. O to B is called 3B. Find in terms of A and B the vector O to M. So we need to get from O to M. So we'll start by saying A to B. How can I get from A to B? I can go minus 4A plus 3B. So A to B is minus 4A plus 3B. So A to M must be half of that. So half of this minus 2A plus 1.5B, 1.5 B's, or 3 over 2B. So now we know A to M. We can go from O to M by going O to A, and then A to M. So O to M is going to be O to A, and then A to M. So O to A is 4A. A to M is minus 2A plus 1.5B. So 4A minus 2A is 2A, and we've got 1.5B. So O to M is 2A and 1.5B. So that was our week 11 review. There's an assessment now available. The link will be in the description of this video or at the bottom of the page on the website.